Hi everyone, this is Stephen from Design Fusion. If you check back at our NX parting line tips part 1, we went through some options on how to create the best parting line with good core and cavity steel conditions. In this one, we're going to be looking at the same part again, but in this case, rather than the decent parting line that we pulled off here to avoid any feather edges in core or cavity, the customers made a change and they want to pull this doghouse with a mechanism. So one thing I should show you first is the user interface here in NX. You can change to dark theme, which is helpful if you're working in different lighting conditions. So I'll go back here. I'm going to cut a section so we can look through that area. And flat to the mold, it would be undercut, and normally you'd ask for part concession from your customer, but sometimes they won't budge on it, so you're going to have to pull it on this angle. So the first thing we can do is take a look at measuring with the new measurement dialog box that's come out in NX. And we can grab this face to get the vectors from it based on the draw vector here, and we can reverse our vector and get the measurement angle there 10 degrees. We can do the same for the other face and reverse that. And we've got 20 degrees. So we could get something in there, maybe a 15-degree angle, 12-degree angle, whatever you'd like to put in there for your mechanism accelerating out of there. So one way to do that is we can create an offset coordinate system from the existing one we have there. So we say select coordinate system, we grab it, and that lets us type in an angle as a parameter, and NX will create this parameter in the background for us. So we can do 15, which is down, minus 15 in this case, rotating up. And so I could do minus 12 if I wanted more draft on the top faces. And you can see that creates a new coordinate system in my feature tree. The nice thing is you can click on there and we can adjust that. So if you did want 15, you can just edit it there rather than editing the feature. So now we'll create some curves. So what I'm doing here is creating that original parting line we saw in the other video based on a ZI draw. And you can see it created kind of an odd shape in there. So in this case, we're actually going to be using the draw vector of the mechanism itself on that 15 degrees. And we pick all those faces. And then we give it an angle here. So I'm going to say 75 degrees. So that's going to give us an extra 15 degrees, 90 degrees to our mechanism. Now the old version of NX used to just give you one line. This gives you two, so you don't have to do minus 75 plus 75 to figure it out. You get two lines to work with here. So 75 will give us the plus and the negative draft line on that. Say OK. So we've got our two lines. And now we can go over to the law extension again like we showed in the other video. I'm going to specify my draw vector for that mechanism again. I can come out 1 inch here. I can give it the 15 degree, and I'm going to select these curves. And you can see it's creating a nice 15-degree draft all the way around based on that draw mechanism of a slide or a lifter head that's going to be in there. So now I can just extrude that back just to illustrate what the rest of the body of the slide might be looking like. And in this case, it looked like I have a small, very small gap in the geometry. That's what those little markers are showing me here. So when that happens, we can go into the settings and we can bump up the tolerance. So I'll go up to 1,000. well, it's 1/1000th of an inch, and you can see it still makes it, so it was a very tiny gap. We could also adjust the law extension tolerance first to make sure that it's creating cleaner geometry for us before we do the extrusion. So here I'm going to extract the geometry just so we can look at the part geometry together as if it was a slide nose. And here I'm going to use region, and basically that lets me pick a seed face to start the region. I'll grab it here. So I'm going to start my region using that face. And then at the bottom status line here, it asks us to pick the boundary faces. So basically you can pick all the faces you don't want in your region, and it will spread out and find the rest. And then I have to apply that. So there's my selection there using the region. So if anything inside that region changes, NX will update that selection. And now we can come in here and trim. I'm going to trim to the outer curve. And the red line you just may have quickly seen there is NX doing a quick trim. It now extends the lines to trim to the boundaries if you haven't selected all the geometry yet. And when we look at this area again, this is what we looked at before, undercut on the core, but now that it's on a slide it doesn't matter because that's going to pull out in the direction. So this full draft there, we don't have to worry about an undercut core and changing the parting line like we did before. And you can see that's still a decent 90-degree corner coming off the full ball radius. And we'll have no sharp slide or cavity steel condition in that area. And if we just cut a section to see what the side view would look like there. So since we've got a little bit of time left on this one, we'll give you some quick tips on patching some openings. So there is a patch openings command, and we can choose different types. The Mold Wizard patch will only do Mold Wizard based ones obviously, but we could use a quilted patch here, and we select the faces we want to patch with a quilt. So I'm just selecting the edges of these circles instead here. And you can see it picks up the faces itself and patches them over. So it's a nice quick fill-in for your seal-offs, even without the Mold Wizard product. Now for this clip here, it's a little bit more complex with the sides. So this is where we use the check regions wizard and Mold Wizard. And we'd run a quick check on this body with the die draw and tell it to calculate. You can see it took about 2 seconds to calculate core and cavity. We can color code those, which side is core and which side is cavity. If we had any faces that were zero draft and we needed to help it, we could actually select them here and assign them to the core or cavity. So I'm just going to apply those colors here. We're going to use the Mold Wizard patch surface. So now that it understands which is core and which is cavity, it's showing you all the loops that would be seal-off openings. Now we've patched some already, so we're just interested in this last loop here. And the selected reference faces, these are the faces it's going to use to surround the seal-off, and you can invert those, the inside ones or the outside ones, depending on what kind of shutoff you want. And you can see NX will build you a shutoff. So we can cut a section through this and see what that steel condition is going to look like. And it's already looking kind of tall and thin, and you can see, yes, it'd be kind of tall, hard to get a cutter down. You wouldn't have radii on the sides. So we can alter this as well. If you're not staying exactly within the Mold Wizard tools, you can come out here and do some synchronous commands. We can replace this face and adjust this surface quite easily. Now for the top face here, we can just extend that under lip face there and bring it out to the edge of the seal off. Then we can do a trim conformal to the face here. And then this, we would be able to put rads on the outside of the core and cavity there. You can see when we cut through it as well, it's a nice solid steel condition, so it's not going to bend over when the plastic comes in and hits it. So that's a much better steel condition. So thanks for watching, and stay tuned to this channel, and we'll be adding more blog tool tips like this one.